All right, what I want to do now is we've done two different examples where we've just kind of gone the long way. We've drawn the diagram and listed all of the options to find our totals. In general, this isn't a technique that we want to continue using because it's not efficient, right? Even in that last example, you had 20 total preferences that you found of first choice, second choice of activity you wanted to do on vacation. And it was tedious and the diagram was big and it just wasn't very practical to do. And that's just going to become more and more true, right? If we think about when we're trying to figure out like how many combinations are possible on a lock, there's going to be way more combinations than we're going to want to list or draw a diagram for. So we need to learn this generalized technique. So we're going to look at the two examples and we're going to see what patterns we can find between the two so that we can then try and figure out a rule for a faster way to get this final answer. So let's think about the two examples. So in the activity example, the one that you just did on the worksheet, we found 20 total preferences. Now I left the tree diagram for our meal example up just so we can remember what it looks like and kind of reference it. So if we think about in the activity example, when we drew our diagram, there were really only two columns, right? We had our start point and then there was choose your first activity. Which, if we remember, there were 5 different choices for how to do that. And then after that, we did choose our second activity choice, that second preference. And we couldn't pick the same one again, so then we were down to 4 ways. Okay, I just want to put a pin in that for a second then. So that one broke down into kind of 2 chunks, and then there was 5 ways and 4 ways, and we got a total of 20. Now let's think about in the restaurant example. Well, in this one, we had kind of our first thing was to pick a salad, and then an entree, and then a dessert. So there were 3 different kind of levels to the problem, 3 different things that we had to do. So first it was salad. And for salad, we had 3 choices. So we had 3 ways to pick salad. Then we had entree. And we had 2 ways to pick the entree. Then we had dessert. And we had 2 ways to pick dessert. Now, another good thing to kind of pay attention to with these, and we pointed it out on the worksheet, that in the meal choices, right, what the 2 choices were stayed the same for every different section of the diagram, right? It was always steak or fish, and then always brownie, hot fudge, brownie, hot fudge, brownie, hot fudge. Whereas in your activities one, depending on what you chose as your first activity, the types of activities that showed up after it changed because you couldn't list it again. Like if you had chosen sightseeing as your first choice of activity, you couldn't choose it again, so your list was the other 4 options. But no matter what, there was always 4 options. That part stayed the same. So that's a key thing here, right? It doesn't matter that these were a different 4 things every time. There was always 4 of them. So again, let's try and think about this, right? We had 20 total, where we had this one broke down into 2 things, 5 ways and then 4 ways, whereas this one was 12 total, and we had 3 ways, 2 ways, 2 ways. It broke down to 3 chunks, this thing, then this thing, then this thing, with 3 and then 2 and then 2. Do you see the pattern yet? Can you try and think through what it is? Well, notice if I take that 5 and multiply it by 4, I get 20. And down here, notice, if I take the first 3 and I multiply it by the next 2, And then the next 2, 3 times 2 times 2 is 12. And now we might be wondering, okay, is that really a rule or is that just a coincidence? And I want us to, again, look back at the tree and think about, well, can we be convinced that it's true based on the tree? So really, can I just break it down into these chunks and then multiply those numbers together? Well, it kind of makes sense because think about it. We started with 3 branches, right? We had 3 different choices for salad. Then for each of those 3 choices, there were another 2 choices. So 3 different times, there was a set of 2 choices. Which, that's literally what multiplication is then, right? There are 3 sets of 2, or 3 times 2. And then for each of those, there was 2 more choices. So then for each of these, which there was 6 of because of 3 times 2, there's 2 more choices. So now I have 6 sets of 2, and 6 times 2 is 12. So the key thing, the time that we can use this technique, this multiplicative technique that we're going to define in a minute, is we need to be able to do this. We need to be able to mentally break the problem down into different steps, into different do this and then this and then this, right? Choose your first activity, then your second activity, or choose your salad, then your entree, then your dessert. Break it into chunks where in every single one of those chunks, there's the same number of options based on the previous set of things. And then we're going to be able to do this multiplication. So what we're going to do in the next video is we're going to write that down as a definition. We're going to write it down formally. But that is what this sequential counting principle is, or this sequential counting technique. So we're going to write that down, and then we're going to practice it. We're going to try and see it in some examples. So if you need to rewatch this one again, definitely go for it, because really seeing where it comes from and why it works the way it does is very helpful for remembering both how to use it and when to use it. So then whenever you are ready, move on to the next video.